I have pleasure in introducing an excellent speaker, Mr. Sanjeev Nimkar from Kirloskar Oil Engines, India, and Mr. Ravindra Patki from Vector Consulting.
Yes.
They've done some enormously great job in their organization, that is Kirloskar Oil Engines. This is typically made-to-order products with various configurations, and they brought down dramatically the reduction in their lead time from a couple of months to a week, if I'm not wrong. 1 week, yeah. In fact, you can be calling it now 7 days rather than 1 week. Sanjeev is heading the supply chain management in Kirloskar Oil Engines for a couple of years, and Ravindra is a management graduate from IIM Indore. Indian Institute of Management is a very prestigious organization in our country for management schools. He has also worked for large organizations like Larsen & Toubro a couple of years back. So I'll hand over this podium to both of them to explain to you their journey, what a transformation they brought in their own company in various areas. Phenomenal results. So let's give them a big hand to start.
Thank you. Hello. Yeah. Thank you very much, Ravi.
Thank you.
Good afternoon, everyone. I will just share our journey for Kirloskar Oil Engines Ltd. This company has brought laurels, this implementation has brought laurels to Kirloskar Oil Engines Ltd as well as Vector Consulting Group. In 2015, in a gala award at US, there is a Association of Management Consulting Firms which looks at different implementation across the world and gives best implementation awards. So this company for the project has won the award last year. For Vector Consulting Group, it is the 3rd time we have entered the final, and 2 times we have won this award. So let us look at what has happened in implementation at Kirloskar Oil Engines Ltd from Nimkar.
Good afternoon to all of you once again. Myself Sanjeev Nimkar, as I was introduced just now. Thanks Ravindra for that wonderful introduction with the award this project got in this year itself in New York. Before I start getting inside my presentation, I will start with the whole process, how this entire thing started at Kirloskar Oil Engines in India. I am working with this organization for last 3.5 years. Before that, I was working in a different industry, electronic sector, and this is a mechanical engines and the power generation segment. When I joined this organization, first 2 months, my initial period of joining the organization, my managing director called me and he said, last 2 years we have got a wonderful success in implementing one great project in the organization. They called it as a Parivartan, called a transformation. The name of the project was a Parivartan. We have implemented this and everything is well set here, and you have to take the reins from here to the next stage. Then I asked about what it was all about. He said, in this project, we have ensured that all our customers, the intermediaries, will give us 3 months rolling forecast and 1 month fixed order for us. So that part we have ensured now. And what you have to do now is last 6 months, we have developed a mathematical model of forecasting, finding out the accuracy of the forecast. And you just validate this model and take it from there onwards. And this was an assignment given to me in my first 2 months of joining the organization, that everything is well set. So forecasting model is well set, the accuracy model, the mathematical model is worked out. And I myself being a student of management, and I had done one course during my premier institute where I joined I did my management on forecasting techniques, quantitative models and forecasting techniques. And I knew myself 10 different techniques, and I had applied them in many industries. And everywhere I found out why it doesn't work. And after that, I had joined this company, and in the first 2 months, I was given the brief that there is a mathematical model worked out and you have to just take it forward. With that backdrop, coming to implementation of a TOC was a big change in the organization. So the first task in front of me was to convince my top management that whatever you have been implementing this project of last 2 years and this thing, and then I gave them one classic example which I keep on giving in this TOC parlance is, I asked my managing director a question: have you ever seen a square cloud? He said, what are you talking about? A square cloud? Yes, I asked, have you ever seen a square cloud? And he said, no, impossible. How can cloud be a square? And the whole story started, and then next 2 hours I explained in last my 20 years of experience, how many times and how many forecasting quantitative models I failed in different scenario. And then with that conviction, with that 2 hours of meetings, talking about the forecasting and entire thing, then we started our journey of theory of constraint, and I had some links with the vector team, we called them, and there we started our story of theory of constraint. So from there, where we have reached, so this is the content, all of you must have just gone through that, so I'll go to the next slide. What is unique about our project? In this project, we have handled all 3 of them, like MTA, MTO, as well as ETO as a part of our project, our kind of offerings to the market. ETO is also part of our offerings to the market. So all 3 from the same production line. We have worked out a new way of priority setting in MTA environment without a primary warehouse. We do not have any central warehouse or a primary warehouse, so that's a big thing. So without that, we are managing our show. For MTO, there were multiple bottlenecks, and how do we manage all these bottlenecks together? So that was different or unique about this project. We brought down 4 to 6 weeks was a general entire industry standard of this genset is 4 to 6 weeks. We got it down to 7 days as a assured delivery. And 180 degrees turnaround in cash cycle. So cash to cash cycle, a complete turnaround in cash to cash cycle. So we'll show you how we have done it. The major challenge in front of us was any such implementation, how do you manage the changeover without losing the sales? And in the entire process, we did not lose a sale even for a day. So that's the planning part of it. How did you manage the changeover from one philosophy to completely opposite a second philosophy? And how, with the careful planning of the transition phase, the company does not have to increase inventory. So the classical theory tells us that there will be drop in sales, there will be increase in inventory, and then only the results will start coming in. So in this project implementation, we combated both the environments. Before I get into the details of it, a little bit about Coel. This organization we deal into, it is India's largest genset, that is a backup power solutions which we provide. Around 50,000 gensets per annum we produce in the country. And we also produce engines for our industrial customers. Overall 220,000 or 220,000 is the number of engines which we produce. 85 different applications our engines go for, and various segments, 9 segments, we'll shortly look at that. And global engine population of ours is around 2 million plus. This is our power generation and industrial engines business. So around 60% of business for the company comes from power generation. We also supply to off-highway engines and the spares and service. So that's the total business here. We have agricultural and allied business. We also have international business which contributes around 15%. And we do have a large engines business. Here we make a very high quantum power genset, around 5 megawatt kind of a power gensets we make here, and this we supply to the nuclear corporation in India. For this project, we'll restrict our discussions to power generation business alone. So that's our bread and butter or flagship business for the organization. In this, CPCB norms govern this market hugely. These are the local legal norms which, when you want to supply these gensets to the customers, we need to adhere to these norms. These are similar to pollution norms of any automobile industry. They are almost similar to that. Apart from pollution norms, there is a noise related norms as well. And we supply the products from 5 kVA to 625 kVA and 1800 to 6300 kVA. So these are the two big ranges we supply the products. And entire telecom industry and local retail markets we supply products. So these are our ranges of products which we supply. A big a product size, if we talk about it, is as small as maybe a few square feet to few square meter. That's the volume of the products which we are talking about. We also supply these products for all these applications. So we supply the rump engine, the basic engine, to all these applications, all construction equipments, material handling, all these equipments we supply the products. And our customers here are all the MNCs like JCB, Caterpillar, Terex. All these are our customers in India. These are some of the applications: backhoe machines, transit mixers, compactors, forklifts, road paving equipment, excavator. So all kinds of different applications, and these kind of 85 applications our engines go, and each application has a customized engine. There is no standard engine which can go inside this. So each application has a customized engine. The market requirements. This is a typical of, most of you have seen this in many presentations. This dilemma, whether to order something in advance and keep the product with you for a long time, or just order as late as possible. So in every purchase manager, because our equipments are basically capital equipments, so a lot of purchase managers are also involved in buying these equipments. And this dilemma is a continuous dilemma with the customers. On top of this, the site readiness cannot be predicted. In many situations we have seen the customers, the planning managers, the purchase managers order these equipments 6 weeks or 8 weeks, even 12 weeks in advance. They buy such a hefty instrument, paying big money. The entire industry works on a cash cycle, so paying such a big money, and they are not sure when the site will be actually ready. So many times the equipment is lying there unattended. Sometimes for few months the site is not ready. So these are the dilemma which all the purchase managers are facing. The significant need of these clients, as I just discussed, there are some of the customers who are also looking at impulse buying. When the power situation is fluctuating in the country, suddenly there are power cuts and power outages. So you need this product to be purchased going out in the market within 2 days or 3 days time. The customer wants this product, and that time it may not be available. And there is also another customers who want. For these customers, there is zero tolerance, and the next level customers who go for the planned purchases. So they have this time, but they are not sure how much time, when exactly the site will be ready for them. And when supplies are unreliable and have long lead times, having short and reliable lead times is a significant need of these customers. So having identified these needs, we started this journey working on how to provide the solutions through applying TOC principles. So the complexity involved into our operations are around 300 suppliers of components to us at our organization, 6,000 plus different components coming from 300 suppliers, and we have different engine variants, around 40 plus different engine variants. Going to, this is a new entity who are the integrators of the gensets. We supply engines to them and they make the gensets. So these are around 150 plus suppliers to GOMs. Then genset components around 1,000 plus, and then genset variants, the end product variant is around 100 plus, and 250 plus channel partners. So when you multiply these effects, the complexity in the entire environment which we manage is multifold. And this kind of application of a theory of constraint in this kind of environment, this is the first in itself in this engineering industry in our country. So these are multiple suppliers to coil, giving components and going to the engine assembly. There is a inventory buffer here. Then loose parts in the kit. And this is within the coil environment. After that, after making the engines, we are going into the GOM. These are the integrators who take the engines and the alternator comes, these things comes to them as per our specification, and they assemble the genset here. And then it is supplied either directly to the GOM's inventory and the coil genset dealer. So this is the channel. There are 250 channel members here. And then the product goes to the end customers. So this is the complete existing supply chain through which we used to operate. The planning cycle at coil and at our integrator side. So around 3 months forecast, as I mentioned, that was the norm. Then components procurement basis that. I'll just come to the last part of it. The 28 days in planning the components and then around 7 to 15 days in manufacturing the engines. Once the engine is ready, then it used to go to the GOM side where they will have 15 days of their own components assembly requirement procurement and 7 to 15 days in the final genset. So the total cycle was close to 8-week cycle when this entire product is going to the end customer. So this was the scenario through which we were operating. The challenges for us were long and unreliable order to delivery 4 to 6 weeks. Large component variety, 6,000 components with different 700 genset suppliers. Huge supplier base to manage, and our plant was a type of plant, and a frequent stockouts was a very, very norm because the power cuts in the country, sometimes the power cut is in one state, the other side the power cut is in the other state, and all the time we used to have a mismatch of the stocks. So where there is a requirement, the stocks are not there, and where there is a low requirement, the power is surplus, the stocks are there. So this situation is very, very common, and we have stretched cash to cash cycle here. So with this backdrop, we started working on this project. We call this as a project Unlock, applying the theory of constraint solutions. So I hand over to Ravi to take the solution elements of it.
Thank you. As explained by him, for any A plant environment, if we know, even if one of the component is missing, you cannot build the engine, you cannot build an assembly. So the challenge for this particular plant was simultaneously having all the components available anytime that I want to build an engine, and forecasting was not possible. So the biggest challenge in managing transition, the solution that is applicable for this environment, as we discussed in the beginning, was MTA for the majority of the part, then MTO and ETO. So I'm assuming that the basic TOC is already known to everyone. I'm discussing the challenges that we are facing in transition. So in transition, the biggest challenge that we face time to time is of the J curve. When we start putting our different channel partners on replenishment, what happens is their inventory reduces in the beginning, so which gives a dip in sales for the company. And at the same time, when you are putting someone on replenishment and there are some items which are missing and there are some items which are in excess, the missing items come very fast. Somehow the excess items do not go out of the system very quickly. So the inventory goes up. So this is it's a good challenge that most of the transitions face. So in avoid to stock inflation and dip in sales, what is the dilemma that we had in this particular company? To manage transition well, of course, we have to reduce the supply lead time. Supply lead time is to be reduced because longer lead time of supply increases probability of loss of sale. And dip in sales, of course, if the client says that there is a dip in sales, they may think that, okay, this is not the right paradigm. I don't want to change. My sale is dipping. And in order to reduce supply lead time, it is required that we should have a plant warehouse by which we can hold the inventory and give the stock, material required as fast as possible from the stock. Because reduction in production lead time has significant impact on the overall supply chain lead time. So the moment I put a central warehouse or a plant warehouse, I reduce the impact of production lead time on the supply. On the other side, to manage the transition well, as we saw, we have to control the inventory. And in order to control inventory, why we have to control inventory? Because, as he discussed earlier, the cash-to-cash cycle was already strained for the company. And stock inflation can lead to the thoughts that, okay, we are in the wrong direction. When we implement TOC, the stocks go up. So that something should not happen. So in order to control inventory, the typical, now what we have a challenge is that we cannot have a plant warehouse, because the moment we put a plant warehouse, it's a new stocking point. The moment I introduce a new stocking point, the stocks go up. Now, particularly in this case, company was not holding inventory of FG inside, because they were having their integration partners, which are called GOEMs, Genset Original Equipment Manufacturers. They were outside parties. The engine was going to them. They were integrating it to make a genset, and then they're selling in the market. So company was not holding any of the stocks in FG. The moment I introduce plant warehouse, the stocks go up. So there is a conflict. Now, usually when we discuss of implementation of a plant warehouse, in TOC parlance we say that because of the aggregation that we get due to plant warehouse or a central warehouse, we are able to reduce overall inventory in the system. The assumption is that the lead time for production and the lead time for deliveries and the aggregation that we get from different points whom we are catering will give us this benefit of overall system reduction of inventory. But in case of coil, the problem was delivery lead times were around 10 days. Most of their plants of the genset manufacturers were located around 8 to 10 days from their location, and the manufacturing lead time for any engine was 2 days. If you release with a full kit the complete components of the engines in the shop floor, you get engine in 2 days. So it's a very small part of the total lead time. So we could not go ahead with this of having central warehouse or a plant warehouse. So in absence of plant warehouse, the requirements of all BPRs, the penetration reports which will be implemented at the GOEMs, when we put the replenishment to all the GOEMs, we get the penetration reports from them in order to prioritize and supply the material. They will directly flow to the production. So whatever variability is there at all these locations will directly impact the way production operates. fulfilling complete requirement of an item at one location can lead to locking of production capacity. So we'll come to this as an example, and the chaos at the production plant. So let's take an example. Suppose there is item A, and there are 3 different locations. And the stocks at different location is different. And now the production person has to decide what to produce and at what priority and in how much quantity. The typical solution says that, okay, if this is the gap, one job order will be of quantity 70 with priority red. So the production gets an order of quantity 70 priority red. Here it gets again quantity 75 priority red. And here it gets quantity 90 priority black or red. So this is 3 locations, everyone giving highest priority order. Now combine this with another item which is having different stock positions at the other levels, at the same GOEMs, if we say. So the requirement would be 40, priority will be yellow. Requirement only 10, it is in green. Or 70, it is in red. Now we have 6 combinations available with us. How should a plant manager decide what to produce? Because if I produce complete 70 of this particular item, I may not have capacity to produce item B. Or if I produce and dispatch 70 quantity to this location, what do I do with these 2 people? So when we do not have a plant warehouse, there is a problem in defining what priority should I use for dispatching or producing the material. Second thing, whether the priority which is used for production, should it be same for priority used for dispatches? Because it is possible that in 2 days, some of this priority may change. This is having 70 in red, or say this is having 10 in green. The penetration may go down, and it may, in 2 days of production, it may have a penetration over here. And then I may have to, at the time of dispatches, decide where to dispatch the material. So what we did in this environment is that we said typical approach cannot be taken, and we have to give a priority in very different way. So what we decided is, instead of producing for the complete quantity of each of these items, we said we should add some of the quantities for different color bands. So for item A, the quantity to come out of this red zone is 10. Here it is, say, 15, and here it is 30. So the production gets a priority that red quantity of 30 plus 15 plus 10 has to be produced. So the priority for red is only that much. The rest priority goes in yellow, and then the remaining goes in green. So every day the production gets the priority based on what is the actual color at different locations. They have aggregation of stocks coming from the back end because the quantity is getting produced. At the time of dispatch, again they dispatch in the same way. They dispatch up to top of red, then they go to top of yellow, and then they go to top of green. So this is one of the challenges that we faced, and this is how we had to go ahead. Apart from that, in typical implementation, what we do is a job order is released whenever we see the gap. At the front end, if we see the gap in the penetration, we release a job order. As I discussed earlier, the production lead time is only 2 days. If I release a job without having all the components present, the half-cooked thing will get inside the plant and will only increase WIP. So one of the important rules that we put in place was a full kit. Without all components present, we will not release a job order. And if we decide to release the job orders, they cannot go beyond a certain level. Because if they go beyond a certain level, it again clogs the entire shop floor. Apart from that, in engineering industry, as he was explaining, there are CPCB norms for pollution control. There are many changes which are happening in the engine, or the components are getting replaced or changing and all. So for that, there was a bigger challenge where there were obsolescence of the components and the newer components were replacing them. So there was a requirement for scheduling this phase out of the old component and phase in of the new component in order to make sure that the stocks do not lie around when the engine changes from one design to the other design. So at the end of it, the primary way of working for supply chain was component supply chain, component supply by vendors was coming and residing in the component inventory as it is described earlier. And this entire chain which Mr. Nimkar explained. Now, earlier it was working on forecast. Now it is working on the trigger which is based on the sales which is happening at the genset manufacturer. So everywhere there are buffer levels implemented. So buffer levels are there for the components, buffer levels are there for the engine assembly and the genset assembly. And based on the color priorities, they get manufactured and they get dispatched. This did not happen in very short time. There had been, as he described, we had to take care of inventory not going up and sales not going down. So the steps in which it was implemented is, first we started with component inventory because that was the first need, full kit should be there. And then we said that the GOEMs will be replenished based on the engine requirement. After that, we launched one project which is called Project Bonsai, which was basically to align these raw material components other than engines to make them available here. Then we rolled out the supplier offer in order to reduce the inventory that we are carrying in the plant. So when we started keeping the buffers at the suppliers, the inventory at the plant reduced. This reduced inventory was actually compensated by addition of some stocks at the plant for the engines. So inventory did not go up. Whatever was the reduction, it was changed into keeping the stock, which reduced further the stock levels at the GOEMs. So their working capital also reduced. Then we introduced, once their working capital was reduced, we introduced some inventory at the genset manufacturers. To further reduce the inventories, we said that we will have a vendor managed warehouse. Instead of each vendor keeping at their own end, we created a warehouse outside the company managed by vendors, and now they are catering to this warehouse directly at the aggregated level, which further reduced the inventory at the company. Similarly, we worked on some of the suppliers at GOEMs to make sure that all the aggregation of supply can happen for these 11 integration partners to further reduce their inventory. The second environment, apart from MTA, was of MTO. In MTO environment, as we discussed in the beginning, around 20% of the business is coming from MTO and ETO. And these gensets have special requirements. So some of them require designing, some of them require special parts to be procured. And this is very high touch time environment. Like in 2 days, you get the engine out. You don't have much time in order to reduce these 2 days to 1.5 days. So you cannot expedite. Once an engine is released, it will come out in 2 days. So the key to OTIF was availability of component full kit. That is the only criteria. So in some of the cases, the complete genset for export requirement, which he was explaining in the beginning, and some of the local requirements also, the genset is manufactured inside Kirloskar Oil Engines Ltd, not by the genset manufacturers. And there are engine assembly lines for manufacturing those gensets. So there is an engine line, there is a genset line for assembling. The capacity of these two lines depends on what is the demand for them. And these are not balanced depending upon requirements. They are the way they wanted in the market, these lines are defined capacity according to that. Now, whenever the genset load increased, there was a problem that we had to subordinate to the genset line and manufacture engine accordingly. But whenever the engine load was higher, some of the gensets were getting delayed. So in this environment, the problem was we could not decide whether to make schedule as per genset line or as per engine line. So what we had to actually do is, we had to continuously check which of the line is getting loaded and change the schedule accordingly. So overall timeline for this product, we started this work in September 2012, and we have reached up to March 2012. We have just recently started working on the consumer offer. And other two areas of work involve the spares implementation, the same way we had worked on the spares, and the new product introduction, which is requirement for the CPCB2 norm. So with this, apart from that, there were two phases, as he already explained. One was the changeover of the plant facilities and replacing products. So these were handled seamlessly in order to avoid any stockouts or at the market or obsolescence in the plant. With this, I will request Mr. Nimkar to share outcomes.
Thanks, Ravindra. With this implementation, let us look at it, what kind of results we achieved after implementation of this project. So our cash-to-cash cycle, which was a big constraint at the start of the project, significantly improved, and from cash negative to cash positive. And no company in large equipment manufacturing business has achieved this, at least in India. This is our sales for last these few quarters. This is the collection cycle, and look at the number of days outstanding where it has gone. So after implementation of this project, phase-wise, we could control the complete outstanding, and we are at close to a 1 day outstanding in the market, and this is total outstanding. These are not overdues. So this is a power generation. Not only this helped for power generation, it helped to other BU as well, which is the industrial BU. So here also we got similar results on bringing down the total outstandings and improving the collection cycle completely. We implemented the same principles for the spares, and there also we could get substantial results in terms of cash flow improvement. Look at some of the other parameters. The credit policy, which was at 21 days, we could easily bring down to 1 day without any apprehension. The day we announced the second day, it was implemented with agreements with all our customers, because their inventories had come down by almost 50%. So cash negative situation, we came to the cash positive situation here. The availability, which was 78% at the start of the project, we went to 99%, and this 99% is consistently maintained for more than 8 quarters now. And our order to dispatch, which was 35 to 45 days, is 7 days, and now last 3 months we have gone to the market with the assurance of this, that it is a guaranteed supplies to the customers now. Look at some of the parameters at our integrator, that the channel partner level. Their inventory, as I just said, came down by 50% reduction in their inventory. Their working capital came by 50%. So overall supply lead time from their end to the market also reduced to the 0 to 3 days and 7 days guaranteed, because they are the ones who give the final product to the customers. These are some testimonials which we received during last few months from our industrial customers, where we supply the engines to the construction equipment. This is from swings. This is from Caterpillar purchasing head. And he has specifically mentioned the availability which has improved never before. This is from Swing Stater, again a MNC. They also mentioned about the inventory of engines have come down by 50%. Their own inventories have come down by 50%. This is another supplier. So there are many more like this. So in this segment, we were holding around 35% market share. Now we have, last 1 year, our market share has gone to more than 40% in industrial segment, and we expect it to sustain that level. Some of the qualitative outcomes, obviously the harmony between COEL, GOM and OEM was required to implement this project. Improved relationship with our suppliers. Our back-end suppliers, they are also extremely happy with this way of working, so the relationship went up there. Obviously the customer satisfaction, which is reflected in the testimonials. And last but not the least, this is a very important aspect of this. When there were improvement projects suggested inside the organization, earlier times any project will become an improvement project. In a new change scenario, we know exactly which improvement project should be given priority basis where is the consent lying. So that was a big gain for organization as a whole to focus on improvement projects going forward for the growth of the organizations. On the spares and service side also there was a significant improvements there. Our availability from 71% went to 90%, because once we tested the success on a power generation side, we just implemented this success onto the spare parts side, and there also we got the significant results here. The challenging times of last 3 years, when we implemented this in 2012, the market was actually a very high booming market in India, and suddenly the economy started slowing down. The slowdown of economy improved the power situation in the country, so we went into a double whammy. So how the market went about it, and these are the externally published numbers. So the market came down sharply in last 3 years, almost 20% decline in the market. And look at how we fared in one of the very important segment of our high horsepower engines. So this is where the COEL started the project at around 21%, and we have reached around 35% in the high horsepower segment. In this segment, and our competition has continuously kept on coming down. So this was our major competitor, so who started losing the share and we started gaining the share. Although the top line could not be increased because the market itself was shrinking, but the market share substantially went up. These are some numbers from, this is COEL's data from a published results, and this is our major competitor from a published results. So look at all the parameters, the COEL has improved on that, and on the similar parameters, whether it is a net cash to cash cycle of minus 167 for our major competitor, whereas plus 18.9 from here to here for COEL in the same period. And these numbers we have picked up from the published balance sheets in the open domain. That's it from our side. Any questions?